So we decided to confirm the inclined plane equation or law. First of all, an inclined plane is a simple machine which has a sloping surface and it is used to raise heavy objects. Inclined planes connect a lower level to a higher level and they make work easier. Work is when you apply a force, a push or a pull, and it moves an object. The advantages of the inclined plane is that it doesn't move, therefore it's very stable, and it also can be at any angle for maximum flexibility. But a disadvantage is that you still have to move the thing that you want to elevate. An inclined plane gains mechanical advantage by trading the amount of energy required to lift an object for increasing the distance over which it must travel. For example, walking up a 60-foot tall hill is easier than climbing directly up a 60-foot cliff would. However, you also travel further than 60 feet in order to do so. Discounting friction, the same amount of energy is expended in both cases, but scaling a cliff requires that energy to be expended in a shorter period of time. Some scientists think that the wedge, which is another simple machine, is simply an inclined plane. The difference is that it is used for another purpose. The mechanical advantage of an inclined plane describes the relationship between the length of the slope and the height of the inclined plane. It can be calculated by the following formula. Distance load travels over height low is lifted. And talking about calculating the effort needed to raise a known load, we use the formula load over effort equals distance over height.
The history on the inclined plane, strictly speaking, no one invented the inclined plane, since the actual object is presented in nature and was being used even before the principles behind it were understood. Archimedes, the ancient world's great mechanic, scientist, and inventor, did not even include the inclined plane in his list of simple machines. However, it was clearly a fundamental engineering tool in the ancient world, and even if no one was given it a place with the screw or the pulley, the idea of the inclined plane as a machine in its own right began to take shape during the Renaissance, and Galileo included it in his work on mechanics, but he did not invent it.
Okay, the inclined plane formula will be Fp times L equals to W times H. Fp means force times L, which means length, equals to W, which means works, times H, which means height. And we don't have to forget that force always needs to be in newtons as much as the work. And the length and height should be always in meters.
As I previously said, we need work to move the object through the plane. So that's why the formula to get the work done of an object when it is lifted is the same as the one used to get the work done by an object that is being raised on a plane.
We have another formula so we can solve the inclined plane problems, which is friction equals to coefficient of the friction times the normal force. And the normal force is the object that extends perpendicular to the surface.
True examples of inclined planes are wheelchair ramps, which are very helpful not only to people with a disability, but also to those who have an injured leg or for the elderly that can climb the stairs. Slides are not only for playing or having fun, they also help to transport heavy objects to a flat surface. The last example of inclined planes are these stairs. We use this inclined plane every day. They help us to go from one floor to another.
Now I'm going to mention the measurements of all the materials. First, the black box has a mass of 250 grams, and the pink box has a mass of 100 grams. The length of the blue ribbon that is connecting the two boxes is 71 centimeters, and the length of the table, which is in this case representing the inclined plane, is 80.07 centimeters. The height of the table while resting on the books is 24 centimeters, and the angle that is created with this height and this elevation is 20 degrees.
On today's experiment, we're going to recreate an inclined plane. For an inclined plane, we are going to use a couple of books to recreate the height. We're going to use a piece of wood to recreate the plane, and two boxes, one with weight and the other one empty. The two boxes need to be attached with the ribbon. So now, we pile the books together. We now place one end of the wood board on top of the books and the other end on top of the table. So now, we place the boxes. The one with weight, it needs to go on top, and the empty one needs to be on the bottom. And now you can see that the weight of the box is going to move the empty one. This is due to the formula for the inclined plane. The formula of the inclined plane is the following. Is the potential energy times the load that is equal to the weight times the height.